Hi, this is Barry from Seagull Electronics. If you haven't seen our introductory video, check it out. We make the only Bluetooth PCB designed especially for antique radios, and it's brought new life to many old radios and even empty cabinets and old boom boxes. The coolest thing about our retrofit is that you can control the Bluetooth audio using the original knobs on your radio or from your phone. It also controls the original dial lights, so the dial will look just as good as it did when the radio was new. Your radio will provide a great user experience plus high-quality, powerful audio. When you retrofit your radio, the original electronics will be left undisturbed, but the radio will now be a high-quality Bluetooth-powered speaker. You won't reduce the value of the radio as an antique because the radio can easily be returned to its original condition. In this video, I'll show you all the steps of retrofitting this 1936 RCA radio. I won't assume that you have any experience with old radios or even electronics for that matter. I'll do the retrofit using basic hand tools, a soldering iron, a wiring diagram, and the instructions that came with the retrofit. If you have any problems doing the retrofit, send us an email and we'll help you. The amount of time needed for the retrofit depends on how many of our product's features you want to use and how original you want the radio to look from the back. In this video, I'll show you how to connect all the PCB features and give you tips and tricks for hiding the wiring, PCB, and new speaker in the back of the radio. Just do the retrofit that suits your needs. By the way, you're looking at the back of the retrofitted radio here. In this video, I'll use parts from the potentiometer and wiring kit, which you can find on our website. If you're not an experienced radio restorer, the parts in the kit and the instructions on how to wire them will really help you. Plus, they'll save you trips to the hardware store and shipping from specialized suppliers. But if you're an experienced radio restorer, you probably have these pieces in your shop already. The first step is to take it apart and remove the dust, grime, and mouse nests. I'll start with the knobs. They should just pull off with slight pressure, but in this case they needed more convincing. The knobs can be brittle, so to keep from breaking them, I use this flat-bladed automotive interior tool to gently pry them off. Next, I'll remove the chassis with the old electronics. It can be heavy, so I'll loosen the screws from the bottom so it won't fall. After removing the chassis, I'll number the tubes and make a simple drawing so I can put them back where they belong. The plastic dial cover is in pretty bad shape, but I can buy a new one from this site. There's a colorful dial under that faded plastic, but it's in bad shape also. Fortunately, I can buy one here. These dials really look great when we're done. The retrofit PCB will drive the dial lights using the socket already in the chassis, and both incandescent and LED bulbs are included in the potentiometer and wiring kit. Fortunately, this radio has a chassis, so the dial will fit perfectly behind the bezel. But if you have a cabinet with no chassis, here's a trick to keep your radio looking good. Place a piece of grill cloth over the opening and then use the bulbs and sockets from the potentiometer and wiring kit to light it from behind. It's not a perfect solution, but it still looks good. Like many radios, this one had an old mouse nest in the chassis. To clean it, I put on a dust mask and blew it with compressed air. Then I used a rag with dish soap to clean it further. To get the best result, it's best to visualize and plan the entire retrofit before starting. We'll start with the potentiometers, or pots for short. You have at least 3 options. If you aren't an experienced radio restorer, the easiest option is to use the 2 pots that come with the potentiometer and wiring kit. The one with 5 solder lugs is used for on, off, and volume, just like the original radio, and the other is used for tone. These pots will usually fit in your radio chassis after you unscrew the nut from the original pot and push it back into the cabinet. I won't tighten the new pots yet because it's easier to solder the wires to them when they're out of the chassis. I'll secure the old pots with zip ties so they won't rattle when this radio pounds out the audio. If your radio doesn't have a chassis, here's a great trick. You can use the adapter plates and screws from the potentiometer and wiring kit to secure the pots to the inside of the cabinet. You just mount the pot to the adapter plate and then secure the plate with 4 number 2 screws. Since you don't have a chassis, you probably don't have knobs either, but you can buy retrofit knobs from lots of sources on the internet. I'll show you how to trim the pot shafts in a bit. The last pot option is for experienced restorers. If the original pots are in good condition, or if you've restored them, you can just use them. Just disconnect the old wires and follow the schematic in the instructions. Also, the instructions show that there's a configuration shunt on the PCB that allows you to specify whether your pot has a linear or audio taper. We won't use a pairing switch for this retrofit, but the instructions show how to use the band switch from the radio as a pairing switch. Most customers don't use a pairing switch. They just let the system enter pairing mode when it turns on. This is easiest because when the radio turns on, the dial lights will flash and then you can either just pair or connect. If you don't pair or connect within 5 minutes, the dial lights will stop flashing. If you don't like flashing dial lights, you can disable flashing by installing configuration shunt C3. When you listen to a 1930s radio, you'll find that they produce a huge sound. An advantage of our retrofit is that it provides the same or more output power and it'll easily fill a large room. If your radio is pre-World War II, the existing speaker will have more than 2 wires connected and you'll have to replace it with a modern one. I'll pick a speaker that's close to the size of the original speaker and then cut a mounting adapter that'll mate the new speaker to the original speaker mounting screws. I'll remove the speaker and then make a simple tracing. Now I can shop for a speaker. The instructions for the retrofit provide recommendations for speakers and I'll use one of them, the Visiton BG20. I cut the adapter plate from 1/2-inch plywood. To keep the speaker from drawing attention, I'll peel the sticker off the back, clean off the adhesive, and paint the back a dark color. Now I can secure the plate to the cabinet and then the speaker into the plate. No matter how damaged the original speaker is, it's a good idea to save it. This preserves the radio's value as an antique and it makes it possible for someone to restore it to its original condition someday. If you're restoring a large console or any radio with a roomy cabinet, consider storing the old speaker by just mounting it inside the cabinet. The retrofit PCB accepts audio from analog sources using the stereo aux input. I really like this feature because some of my favorite CDs aren't on the streaming services and this lets me play them. Some customers with radio phonographs add a preamp to their phono radios and connect the preamp outputs to our aux inputs. The potentiometer and wiring kit includes the audio jack and a toggle switch to select aux audio. The switch will mount in the hole left by the old power cord and the audio jack will mount nearby. As with the pots, I'll hold off securing them in the cabinet because I want to solder the wires on them first. The final part of the planning stage is to select a mounting location for the retrofit PCB and power supply. This is a roomy cabinet, so it'll be pretty easy. For the best Bluetooth range, I'll mount the PCB as high as possible in the cabinet and away from the metal chassis. The other advantage of this mounting location is that people usually look down at radios, so with the PCB at the top, it will be hidden. I've placed the PCB so one connector faces the side and the other faces the inside, which will hide the wiring better. I took advantage of the large case size to separate the Bluetooth antenna from the chassis, but the Bluetooth range would be fine with the PCB as close as a few inches from the chassis. The wood on this radio is old, so I'll drill pilot holes for the PCB mounting screws. I'll mark the pilot hole depth with a piece of tape and drill shallow holes for the PCB and power supply. I won't secure the PCB to the cabinet until I connect all the wires to its terminal blocks. I'll secure the power supply with, of all things, these picture hangers and then a zip tie. I don't want the power supply to slip or rattle, so I put non-hardening adhesive on its back surface. By letting it fully cure, it won't stick to the top of the radio. This radio has nice thick sides, so I'm not worried about mounting the PCB with pilot holes and wood screws. But I want to show you a trick for mounting the PCB when your radio has really thin sides. This Philco radio has thick pieces of wood on the sides and corners, but the sides are only about 1/4 inch thick, so I don't want to screw into them. I cut this piece of plywood, painted it dark, laid it in the channel, and then secured it with metal straps. This let me mount the PCB without worrying about driving a screw into those thin sides. At this point, I've planned the retrofit and I'm ready to get to work. I'll start with the chassis and then work my way up to the speaker and finally the PCB. Before I install pots in the chassis, I have to shorten their shafts and solder wires to them. I'm not the most mechanically inclined person, so for me, this is the hardest part of the retrofit. As you can imagine, I'll measure carefully before I cut and file them. If you make an error, don't feel bad. You could just go to this website and order another. I'll use an original knob shaft to show how far the shaft should stick out from the cabinet face. I set the chassis in the cabinet, and with the new pots fitted, I'll measure the distance between the cabinet face and the end of an original shaft. Then I make marks showing where to cut the new pots. When I cut the shafts, I make sure to clamp the end I'll discard in the vise. The next step is to file the end of the shaft so it'll fit snugly into the knob but not stress or possibly split it. One of the original shafts gives me an idea of what the result will look like. I've masked the pot with tape so I don't get metal filings in it. I can't emphasize enough the importance of checking the fit frequently. The difference between a snug fit and a knob that will slip off can be just a few file strokes. Here's the result with the tone pot. I'll do a test fit and then do the on-off volume pot. Now I need to wire up the parts in the chassis. The instructions for the potentiometer and wiring kit show this wiring diagram, which I'll use. If you prefer schematic diagrams, you'll find this one in the instructions for the retrofit, but we'll use the first one. If you use the wire colors as shown in the diagram, the kit should have all the wire you need. My goal for wiring the chassis is to have all the wires come out of the chassis in a neat bundle. I chose a location toward the front of the radio where it'll be well hidden, and here's a sneak peek. If you're a radio expert, you may be concerned about the length of the wires from the pots and how close they are in the bundle. The signal from the pots are actually DC, not audio, and any noise or audio pickup is digitally filtered by the microprocessor on the PCB. The wiring diagram suggests that since we have a chassis, we can connect all the black wires to the chassis and then connect a single black wire between the chassis and pin J13 on the retrofit. This is actually pretty easy because most radio chassis have lots of bare pieces of wire connected to chassis ground lugs, and reducing the number of wires between the chassis and the retrofit board just makes your wiring look better. As I do the wiring, you'll see that I'll connect the black wires from the components to ground points on the chassis, and then I'll connect a single black wire from the chassis to pin J13 on the PCB. I wired the pots based on the wiring diagram. The pots are about 10 inches apart on this radio, so the red and black wires between them are 10 inches. Also, instead of connecting the black wire from the pots to the PCB, I just connected it to a wire that connects to the chassis. Here's how the pots and wiring look in the chassis. By the way, are you wondering what this is? Like most of us, I make mistakes when I do wiring. I just spliced the wires and covered the splice with a piece of shrink tubing from the potentiometer and wiring kit. I connected wires to the aux connector and secured it in the chassis. Then I wired the aux enable switch and also secured it in the chassis. Since the wire colors green, blue, and orange are also used for the pots, I've marked them in the wiring bundle. The wiring diagram shows a gray wire and a black wire going to the dial light, but the dial light on the radio just has a single wire. This is because the dial light socket makes an electrical connection to the chassis. The original wire is crimped and soldered to the light, so I cut the original wire, spliced the new gray wire to it, and then insulated the splice with a piece of shrink tubing from the potentiometer and wiring kit. I installed a new bulb and clipped the socket into the chassis. By the way, doesn't that new dial look great? I could have routed the gray wire directly to the PC board, but it looks nicer to snake it into the chassis and then out of the wire bundle. The potentiometer and wiring kit provides both LED and incandescent dial lights, but I chose an incandescent bulb because I prefer the look of an incandescent bulb instead of the LED, and I'm happy to replace it when it burns out after about 1,000 hours or so. But if you don't want to ever have to worry about replacing the bulb, the LEDs look great too. Though this radio uses only one bulb, the Retrofit PCB will drive up to three 6.3 150 milliamp Type 47 incandescent bulbs or three 6.3 volt LEDs connected in parallel. Since I used an incandescent bulb, I'll be connecting the gray wire to the PCB at J1 pin 4. If I used an LED, I'd connect the gray wire to J1 pin 5. You may have noticed that the incandescent and LED bulbs in the wiring kit have a bayonet base where the bulb for this radio has a miniature screw base. If you let us know which base you need, we'll try to include the correct one in the kit. The last step before mounting the chassis is for looks only. I like to see the speaker wires come from the radio chassis instead of the PCB, so I'll do the same trick as I did for the dial light wire. I'll twist the wires that go up to the speaker for about half their length, and then put the untwisted half in the bundle. Finally, I'll put zip ties around the bottom part of the bundle. Here's an optional step to hide the wires even more. I had this large piece of shrink wrap in the workshop, so I used it to cover the bundle. It's pretty nitpicky, but I just wanted to hide those colorful wires in the cabinet. With chassis wiring complete and the new dial installed, the chassis is done. I'll mount it in the radio with its 4 screws. You can see how the wiring bundle will be hidden in the front corner of the radio. With the radio upside down, I'll connect the wires to the terminals on the PCB. You might be tempted to tin the wires with solder before securing them in the screw terminals on the PCB, but the manufacturer of the terminals recommends that you don't. Just remove about 3/8 of an inch of insulation, insert the exposed end into the terminal, and secure the screw. I'm not using a pairing switch for this radio, so I'll connect a piece of gray wire between J1 pin 1 and J1 pin 2 as shown in the wiring diagram. This will cause it to go into pairing mode each time it's turned on with the off-on volume switch. Here are the wires connected to J1. The black wire on J1 pin 3 is the one that connects to the radio chassis. And here are the wires connected to J3. You can see there are no black wires connected to pins 5 or 7 because we use the single black wire between the chassis and J1 pin 3. Next, I'll install any configuration shunts I need. There are 6 shunts and they're described in the instructions. For this retrofit, I just need to install the shunt on C1 because the on-off volume pot from the potentiometer and wiring kit has an audio taper. I trimmed the wires and secured them in the screw terminals, and then mounted the PCB with the nylon spacers and screws. Then I mounted the power supply to the D-rings with a zip tie. The retrofit is complete, and I'm ready to plug it into the wall and test it. I'll turn it on with the on-off volume knob, and the dial light should begin flashing. Since this device is new to my computer, I'll need to pair with it. When it pairs, the dial lights stop flashing. I'll use my streaming service to play some music. I test volume adjustment with my computer. Then I adjust the volume with the knob on the radio, making sure the volume control changes smoothly as the knob turns. If it didn't, I'd either remove or install the shunt at C1. The next step is to check the tone adjustment. Turning the knob counterclockwise should give bass boost. Then I'll turn it up loud and use my ears and fingers to look for any mechanical vibrations. Next, I'll test the aux connection to my CD player. This 3.5mm to RCA cable will connect the CD player to my radio. With the aux switch on, I'll make sure I can play a CD. Everything works and it sounds fantastic. Though it was a lot of work, it'll only take a few minutes to dismantle so I can send it out for cabinet repair and finishing so it'll look as good as this one. After that, it'll live in the tasting room at a local San Diego winery where the sommelier can play and share music with the patrons. Before signing off, I hope you won't confuse the amateurish quality of this video with the quality of our product. After a 30-year career as an electrical engineer, I became professor of electrical and computer engineering at San Diego State University. I'm also a professional trombone player in the San Diego area, which explains why I'm so passionate about this product. Doing projects alongside my students makes me a better professor, and this one spawned 3 years of student projects, many course lectures, and a published paper in the trade press. If you have questions about the instructions or have trouble with the retrofit, just reach out via our email address from the instructions. Finally, I want to thank our many customers for passing along many of the clever techniques in this video. If you want to share your insights, please send feedback to our site. Whether you're retrofitting a 1930s radio like this one, a smaller Bakelite radio made after World War II, an empty cabinet, or even an old boombox, I hope you enjoy doing the retrofit and that it fills your home with great sounds for many years. Thanks for watching.